Okay, lesson 39, some difference in double angle identities. So what we're doing now, you look back at your formula sheet, is kind of the rest of them here now. It's all these guys down here. Other than, yeah. So we're doing the rest of this mess. Okay, so first off, it says, does cos 30 plus cos 60 equal, like, does it equal cos 30 plus cos 60? So this would be cos 90. And this side, well, so cos 90. And while we're doing this here, right, cos 90, if you think about that, right, where is cos equal to 90 degrees? It'd be 0, right? Cos would be equal to 0 at that point. Okay, so the x value would be 0. So that's equal to, and then cos 30 would be, that's actually root 3 over 2 at that point, if you're looking at the unit circle. And cos 60 would be a half. So no, that's not going to give me 0, right? So that's 0. This side will not be 0, so no. I don't know why we started with that, but just to show you, I guess, that pattern doesn't work. But then we do have some of these other patterns that do actually work. So sine A plus B, it's a bit more complicated than just, sine A plus sine B, right? It doesn't work out quite that nice. Yeah, so you guys have these on your formula sheet, so you don't have to memorize them, but you should probably, again, be just good at starting to recognize them. So let's just jump into it. So if I'm looking, let's say, at this question here, right? So 1a, it says write each expression as a single trigonometric ratio. So I'm looking at this, being like, okay, how could I figure that out, right? Well, sine of 23 degrees and then cos of 22. What I'm noticing here, like, look for the pattern. So this would be like, theta 1, it's 23 degrees. And then theta 1 is over here too, right? 23 degrees. Theta 2 and theta 2, they're both the same. So see if you can find that pattern up here, right? So where I've got sine, or maybe I should call it A and B, just so that they look the same. So this would be A, and that would be A, and that would be B, and that would be B. Okay, so do I have a sine A cos B? So sine A cos B, yep, plus sine B cos A. Yeah, that's that one, right? So we can just put this in now as this side. Right, so sine A was 23 degrees, we said, plus, and then B was 22 degrees. Okay, so in the end, this would be sine of 45 degrees. Okay, and it said just write it as a single trigonometric ratio. But you could also probably see where is sine equal to 45 degrees, and that would be at that would be at root 2 over 2. So you could have really wrote the answer there as well, too. Okay, hopefully that made sense. That root, maybe I'll show you. Root 2 over 2, so 45 degrees, right? The sine value is root 2 over 2, or the y value there. Okay, next one. All right, so now we've got cos, and again, let's just call that like A, pi over 4. We'll call that, it's a different one, so that's B. And that's the same as A, and then that's B. So let's look back to our formula there, right? Do we have a cos A? So cos A, cos B, right? Cos A, cos B, minus sine A, sine B. So that's the one we're looking for. So now I can use this side. So cos A plus B. So it's going to be cos A plus B. So that's going to be cos of pi over 4 plus 3 pi over 4. All right, so if you actually add those fractions, you'd end up with cos of pi. All right, so what is cos at pi? That'd be -1. Okay, so again, maybe we'll just show you there why. So at pi, right, cos, the x value was -1. Okay, whenever I see one of these ones where it's like tans, and you've got a bunch of like weird stuff going on there, like written like, in that kind of a way, if that makes sense, that looks really similar to these guys, right? One of those two identities. Okay, so if we label these again, right? So they'll maybe call that A and that B. And then 95 we said was A and that B. All right, so tan A minus tan B. Right, so first off, even with the minus, I'm kind of looking at the bottom there, right? And then 1 plus A, or 1 plus tan A tan B. All right, so that's the bottom, right? So that's this. So tan A minus B. All right, so that's good. We can rewrite this as tan A minus B. So tan A was 95 degrees. B was 35 degrees. Okay, so that ends up being tan of 60 degrees. Okay. So then again, you could solve for all of that too by writing. Maybe I'll just do it. We'll actually do it. All right, so tan 60 degrees, that'd be the same thing as sine 60 over cos 60. Okay, and then you'd be thinking of your unit circle, right? So 60 degrees, so that's here, right? 60 degrees, you're having sine over cos, so 3 pi over 2 over 1 over 2. 3, oh sorry, I said pi, didn't I? That was stupid. No, it's root 3 over 2 divided by a half. Root 3 over 2 divided by 1 over 2. Okay, so if I flip all of that, the 2's cancel, and you end up with just root 3. Okay, hopefully that's making sense there. All right, so determine, now we're just going the other way. So for 2, it says determine the exact value for sine 15. So here's the problem. Here's why we have to do this instead of just figuring it out, right? Is that I don't know what sine 15 is, right? So if I'm looking at the unit circle, I don't have like a 15-degree thing, right? I'd have to get into triangles and, I just don't know what that is. So what we want to do is keep it to the unit circle. So the little trick that we're going to do is we are going to rewrite sine 15 as two angles that we do know, right? So I'd be looking at my unit circle and I'd be trying to make up 15 degrees out of some of these other degrees that we have. Okay, so I'd be like, okay, so can I go 60 minus 45, right? Or can I go 45 minus 30? So something like that, so I can end up with like 15 degrees. So let's go 45 minus 30 because I know what those are, right? Hopefully this will make sense in a minute. So I'm going to rewrite this as sine of 45 degrees minus 30 degrees. And the reason why I split it up like that is because now, the way this is written, I can call my 45 degrees A and my 30 degrees B. Okay, maybe you see where I'm going here. A and B, okay, so then looking at my formula sheet, do I have a sine A minus B? Right, because that's what I wrote that as now, right? Sine A minus B. Sorry, I'm clicking around a lot. Okay, so sine A minus B is that one. Right, so I get to rewrite this whole thing as sine A cos B minus cos A sine B. Sine A cos B. Okay, so I'm going to rewrite this as sine A cos B. I always have to look at these two, so sine A cos B minus cos A sine B. Okay, so now hopefully we can figure this out as a single, like an actual exact value now. So sine A was sine 45. So sine 45 degrees times cos, and then B was 30 degrees, minus, and then cos A, so cos 45 degrees, and then sine, and then sine B was 30 degrees. All right, so now that's written like that, I know what each of these guys is, right? I can figure those things out from my unit circle, right? So sine of 45 degrees, well, that's root 2 over 2. right? So root 2 over 2 times, and then cos 30. So cos 30, right? Cos 30 is root 3 over 2, right? That's the x value at 30, right? Cos 30. Okay, so root 3 over 2 minus, and then cos 45 is also root 2 over 2, and then sine 30 is equal to a half. Okay, now we just need to simplify this up a bit. Okay, so if I'm multiplying, so remember when you're multiplying radicals, right? So root 2 times root 3, that can just be written as root 6 over 2. Sorry, over 4. 2 times 2 is 4. Should know that. Okay, minus, and then this is root 2 over 4. Okay, so in the end I've got root 6 minus root 2 all over 4. And that's it. That's all we can do, right? You can't really rewrite this any other way. So, okay. So that's the answer. That's the exact answer, right? So this is, you know, we haven't rounded to any decimal places like you would have had to, right? If I would have put this in, I would have had to have rounded that answer to however many digits, right? This one, we kept it in the square root form. So this is as exact as the answer can be. And so that was the whole point there, right? Okay. Now, hopefully you guys get better for room. I'm going to erase this for now, just so I can actually write beside it here. Okay, so now we need to rewrite cos of 7 pi over 12, and we need to rewrite that as things that I know, right? This can be a tougher one with the fractions, right? So I think the way that I would start thinking about this is I'd write this down. So 7 pi over 12. So I'd say, okay, 7 pi over 12. All right, so that needs to be made up of two other things. I'm going to write them both over 12. So something over 12 plus something over 12 gave me 7 pi over 12, right? Okay, so now I'm just looking for numbers on the top that add up to 7, right? So I could say, okay, well, what about, 3 and 4? So I'd say like 3 pi plus 4 pi equals to 7, like to 7 pi over 12. So that should be good. And then looking at these right now, I don't really, they don't really make much sense to me. But what if I simplify these? So if I simplify the 3 pi over 12, that ends up being pi over 4, which I do know, right? Pi over 4 is one of the ones I know. And this ends up being pi over 3. Okay? So maybe you tried some other ones and it didn't work out to numbers that we did know. So you just have to kind of do a little bit of guessing and checking there. And the other thing is there could be multiple ways of doing this that get you the same answer. Like sometimes multiple combinations of these things will add up to that angle. Okay, so this is what it was. We're going to split it up into those ones. So we're going to rewrite this as cos of pi over 4 plus pi over 3. Okay, so this is my A, that's my B. Okay, so now I'm going to look to my units, my formula sheet and say, okay, what's that equal to? So cos A plus B. So I'd say, okay, cos A plus B, well, that's that one, right? So cos A cos B minus sine A sine B. Okay, so cos A cos B. All right, so let's go, so cos of pi over 4 times cos of pi over 3. And then was it plus or minus? Minus sine A sine B. So minus, and then sine pi over 4 times sine pi over 3. Okay, so now again, we just need to clean this up. Okay, so cos pi over 4, so that's 45 degrees, right? Pi over 4. So cos pi over 4 is going to be root 2 over 2. Okay, and then cos of pi over 3. So cos of pi over 3 is a half at 30 degrees there. Minus sine pi over 4 is also root 2 over 2. And then sine pi over 3 is root 3 over 2. So you start to notice that it's pretty much always going to be these same numbers, right? So you gotta get good at these numbers, okay? All right, so now this ends up being root 2 over 4 minus root 6 over 4. And this one looks similar to the last one, but it ends up being root 2 minus root 6 over 4. All right. So now I've totally run out of the room for that one. So hopefully, maybe you guys all have enough room there. I'm going to add a new page so I can just do this one. So tan 165. Okay. So, like I said, hopefully you guys had enough room. Maybe grab a new sheet of paper if you need to, if you took up a bunch of room there. Okay, so I need to split 165 into some numbers that I know, right? So this one's a little bit tougher because you have to go past 90 degrees here to find numbers that work. But I'm thinking, okay, 165, right? 165, I'd almost start, like it was me thinking about this, I'd be like, okay, 165, what if I start subtracting, you know, on my unit circle? What if I, because I know it's going to be numbers of like 30, 45, and 60. So if I go, so 165, right? And I start like, you know, subtracting 30, 45, and that type of thing. Like seeing if my numbers work out nice then, right? So 165 minus 45 is 120. I'm like, okay, well I know what 120 is too, right? 120 is also on there. So 120 and 45 make up 165. Or just try some things. I'm sure you guys will be able to figure it out if you just try some of those numbers. So I'm going to rewrite this as tan 45 plus 120 degrees. Okay, and then again, I need to rewrite it in the proper form here. So that ends up being, so here we'll call this A and that B. And then again to my formula sheet, so it's A plus B, so tan A plus B. So tan A plus B, that's this one. Okay. Okay, so if I'm writing that one out, it's going to be tan 45 plus tan 120 divided by 1 minus tan 45 tan 120 times tan 120. Okay, so now tan of 45 degrees, that's an easy one. Tan of 45 degrees, like both A or X and Y are the same length, so they end up giving 1. Right? So 1 plus, now tan of 120, so tan of 120, tan of 120 there, right? So that is going to be similar to tan of 60, right? That's going to be a similar thing. And that's going to be root 3 over 2 divided by negative 1 over 2. And maybe you've done that one enough times that you know that the 2's end up canceling when you do that, if you want to do that. And then you just end up with root 3. But since I'm dividing by negative, it's going to be negative root 3. Okay, so this is going to be negative root 3 over 1 minus tan 45 is 1, and then tan 120 was negative root 3. Okay, so maybe I'll get a, oh, that's not right. I can write the top, it's just minus, just to make it a little bit simpler there. Okay, so again, now cleaning this up a bit, I've got 1 minus root 3 divided by 1 plus root 3. And that was just from here, right? Because I got minus a negative, right, happening there. So I called that plus. So now that is my answer. That's technically my answer. But I've got that square root in the bottom, right? I've got that radical in my denominator. So going all the way back to math 20-1, right? How do I get rid of this? I need to multiply by the conjugate pair. So instead of 1 plus root 3, it's going to be 1 minus root 3. And I can't just do the bottom. I also have to multiply the top by 1 minus root 3. Okay. Maybe I'll put that in brackets so we do this properly. So now the top here, if you expand the whole thing, right, you end up with 1 minus 2 root 3, right? This is just foiling this. Okay. Plus 3. And then divided by, and then 1 minus 3 is what? Because your square roots cancel, right? And the middle term cancels out when you do that. So clean this up again, we end up with 4 minus 2 root 3 over 2 over negative 2, sorry. Okay. And then I can do a little bit more here. I can do a little bit more because I can factor out a 2 out of the top, right? And then cancel, or just you can maybe you see you can just cancel there. Let's do it. We'll go 2 times 2 minus root 3 over negative 2, right? And then the 2's cancel. So we end up with negative, did I write that? Yeah, just negative 2 plus root 3. The plus came from, because it was negative, maybe I'm explaining too much here, sorry. Negative 2 minus root 3, right? This is how you could have also wrote that. So the negative would be expanded into both of those. So negative 2 plus root 3 or root 3 minus 2. Do the same thing. Okay. Hopefully that worked out. You guys understood my whole process there. All right, so let's go back here. We've got more to do. So now, prove that sine of pi over 2 minus theta is equal to cos theta. Okay. So all we can really do here at this point, right, is rewrite this guy. Like, so this would be A and that'd be B. So just write it out and see if we can do some things here. Okay. So we're gonna write this as, so this ends up being sine. This is one of our identities, right? Just look for the right one. So sine pi over 2 times cos theta minus cos pi over 2 times sine theta is supposed to be equal to cos theta. Okay, so let's just do some things here. Maybe they'll end up working out to be just cos theta. So, well, this part, right, sine of pi over 2, that's straight up and down, right? That's 1, right? The y value is equal to 1 there at pi over 2. So far, that cancels, right? That's just kind of gone. And now I'm looking over here, and I'm like, all right, so cos of pi over 2, so straight up and down, that's the x value on the unit circle, right? That's 0. Cos is equal to 0 at that point. So that's 0. This whole term goes away. Right? So we end up with just 1 times cos theta. This is the only one left on this side now, right? So in the end, you've just got cos theta is equal to cos theta. So yes, that worked out. Okay, moving on. Okay, 5 on this one. I think it's different on the other one. It's weird. Huh? Okay. Given sine A is equal to 5 over 6 and cos B is 5 over 13, where A and B are acute angles, determine the exact value of cos A minus B. All right. So looking at this one, what are we going to do here? So we'll say, so I think the best way to visualize what we're going to do here is I'm going to write, this out in the expanded form here, and then you'll be able to see what it is we're missing, and then what we need to do for the next step. So let's go cos A minus B. That can be written as, so cos A minus B is equal to cos A, cos B, plus sine A sine B. All right, so now what I would like to do is actually figure out what these things are, right? Using my information up here. So sine A, so I'm good for that one, right? I can rewrite sine A as 5 over 6. So that's good, I got that one. Cos B is 5 over 13, so I'm good for that one. My problem right now is I don't know what sine B is, and I don't know what cos A is, right? Because they're different ratios. So what I need to do is I need to figure out more about the triangle that was happening for this one and for this one. Hopefully that made sense. So yeah, so what I want to do is draw out a triangle here. So let's go like this. So I'll say, so I drew my triangle, and this was angle A, right there. Then what did we know about this? So remember, sine is opposite over hypotenuse, right? So that means that if I drew my triangle out, this side would have been 5, and this side would have been 6, right? So that's good, that's great for that one. But if I want to know what cos A is, right, from here, then I need to have adjacent over hypotenuse. So I need this value, right? So maybe you can see what's happening here. We need to use Pythagorean theorem to solve for that one. Okay, so if you do that, let's call this maybe side A. I could say A, I'm just going to do Pythagorean theorem all in one step here. I'll say A is equal to the square root of 6 squared minus 5 squared. So A is equal to the square root of 11. Okay, so that's what A is equal to. So that's what this is. So the square root of 11. All right, so we got that piece of the puzzle. Now I'm going to be able to write in the number for cos A when we get there. So that's that part of it. Now I need to look at the other triangle. Okay, so triangle B. Well, what do we know about triangle B? So up here, well, cos is adjacent over hypotenuse, right? So that means this side was 5, and this side was 13. Okay, so if I want to find this side so that I can solve for sine B, right, then I'm going to have to go, okay, B is equal to the square root of 13 squared minus 5 squared, so B is equal to, ends up being 12. Okay, so now that's what this is, right? This is 12. All right, so now we kind of have all of the pieces of the puzzle. Now we can just throw it into here, everything we need. So let's do that. So we'll rewrite this now. Okay, so we'll write this out again now. So we've got cos of A minus B is equal to, all right, so now cos, well, I'll write it all out again. So let's go cos A, cos B plus sine A, sine B. Okay, so like I said, we know what each of those 4 things is now, so we can just write it all in. So cos A, cos is adjacent over hypotenuse, right? So adjacent over hypotenuse. So that's going to be root 11 over 6. Okay, cos B. Cos B, so I'm looking at angle B here now, right, is 5 over 13. Plus sine A is well, I already knew that one. It's 5 over 6, right? 5 over 6. So 5 over 6. And then sine B, 12 over 13. So 12 over 13. Okay, so if I clean that all up, this part here ends up giving you 5 root 11 over 78 plus 60 over 78. That worked out nice. Actually, I did, yeah. Okay, and then just rewriting this out, all we can do is just write this as 5 root 11 plus 60 all over 78. Okay, so that's it. That's as far as we can go there. All right, so let's continue on. Sorry about the length of this video. It's going to be kind of a longer one. All right, so double angle identities now. So this is the rest of your stuff on your formula sheet, right? So if your formula sheet, that's these ones down here now that we're going to be going through. So lots of formulas to do. So double angle identities are named due to the 2 in front of the angle, so like this one, right? This is kind of showing you sine 2a is just equal to sine a plus a. And if we chose to write this as like, the other way when it was sine a plus b, right? You could rewrite that as sine a times cos a, right? But they're both a's instead of a b like it would have been in the last section there. Plus sine a cos a. Sine a cos a, you get the point. You can see here now that the sine a and the sine a, right? Sine a and cos a, sine a and cos a. So this really just ends up being 2 sine a cos a, right? There's 2 of them. Okay, so that's where that comes from. So 2 sine a is now going to be equal to 2 sine a cos a. Okay, and I'm not going to go through this one. It ends up being something similar. Let's just kind of get right into the identities here, right? Cos 2 theta could be written like, some of these other ones here, right? So that one, yada, yada, yada. So let's use them. So this one says write the following as single identities. All right, so I've got 2 sine pi over 3 and cos pi over 3. Well, that's the same thing as like 2 sine a cos a. Right, so I'm looking at my formula sheet. So I'm looking, so 2 sine a cos a right there. That's equal to sine 2a. So I just need sine 2 of the angle. So this is just sine of 2 of the angle. So 2 pi over 3, 2 times the angle. Okay, so that's it. That's the answer for that one. Now this one, 2 cos squared and 7, right? That's an angle. That's actually just written in radians, right? Okay, so I'm going to look at my formula sheet here. So 2 cos squared of the angle. So I got 2 cos squared of the angle. Was it minus 1? Minus 1, yep. All right, so that's going to be that one. So cos 2 of the angle is what we need to write it as. So this will just be cos, and then 2 times the angle of 7. So this is cos of 14 radians, right? Okay, now see there. So let's look for this one. This would be, can't really scroll down any farther here. There we go. All right. Okay, so I'm looking for, it's probably one of, since we're doing it, it's probably this guy right here, right? So 2 tan of the angle. Oh, no, it's not. 2 tan of the angle. Well, we could probably write it that way. So this up here, tan 25 plus tan 25, and then 1 minus tan squared theta. So I could write it that way because the top of this could be written as 2, right? Tan 25 plus tan 25 can be written as 2 tan 25s, right? So that's the way this one looks, 2 tan of the angle. So I can rewrite this whole thing as just tan 2 of the angle, right? Just that part of it there. So tan 2 of the angle, so that's going to be tan, and then 2 times 25. Okay, so this is just tan of 50. So tan of 50 degrees. Okay. Moving on. So prove the following identities. So remember when I'm looking at these things that we probably want to take the more complicated side and try to work to the less complicated side. And right now, looking at this, I'm seeing, like, you should know this, the cos 2 theta, because usually we want to change those guys into something else, right? To see if we can, like, make it look like a sine squared theta somewhere, hopefully in there, right? So what I'm going to do is I'm just going to rewrite this cos 2 theta as its identity right away. So let's write this out again. So this is sine squared theta is equal to 1 minus, now let's see, so cos 2 theta. So cos 2 theta has a few options. Here's the problem here too, right? So I could write it as this guy. Cos 2 theta could be written like that. I could write it like that one. But really, when I'm doing this question, I've got sine squared theta on the other side. This is kind of looking like the one I'm interested in, right? Because maybe I can cancel one of those sine squared thetas. That's kind of what I'm after. So I'm going to rewrite this as 1 minus 2 sine squared theta. Okay, so I'm going to rewrite this. So sorry, this was 1 minus, and then we're going to rewrite cos as 1 minus 2 sine squared theta. Okay, all over 2. Now let's clean it up a little bit. So we'd say sine squared theta is equal to, all right, so this negative I have on the front here, I'm going to distribute that into both of those. So we've got 1 minus 1, and then this becomes plus 2 sine squared theta. All right, 1 minus 1 is 0, so they go away. And then, oh, sorry, this is all over 2. Okay, so then after that goes away, I've got 2 over 2 cancel, and I end up with sine squared theta equals sine squared theta. That's good. All right, so let's do B. All right, here, so let's see, what do we want to do? Okay, so if I'm looking at this one here, this, by the way, isn't cos squared theta plus sine squared theta, right? This is different. This is cos theta plus sine theta all squared. So if you were to expand that, right, you'd have to write it all out. You'd have to actually do the rainbow for the whole thing, right? So I'm going to do that just because I'm not a big fan of having that all within the squared, right? Maybe I can make some sense of it when I expand that a little bit. So if you expanded that just by doing like the rainbow, right, or just expanding, then you would have cos squared theta, okay, plus 2 cos theta sine theta, right, and then plus sine squared theta, right? So that's what it would all be equal to when you like wrote it all out, right? And that's equal to 1 plus sine 2 theta. All right, so it's supposed to be equal to that. All right, so let's kind of take a look at what we're dealing with here. I've got cos squared theta and sine squared theta, and they really are being added together. Maybe you guys see where I'm going with this, right? That was one of our identities from the last questions we were doing, right? Cos squared theta plus sine squared theta. Well, that's equal to 1, right? The two of them together. So far I can say 1 plus 2 cos theta sine theta is supposed to be equal to 1 plus sine 2 theta. Okay, so at this point, what I'm kind of looking at is I'm like, all right, I got 1 plus, 1 plus. And I'd be hoping that maybe I can make some sense out of those guys, right? Maybe that's one of my identities. That'd be perfect if it was. So let's go, all right, let's look back to sine 2 theta. So sine 2 theta, there's only one of them. And that ends up being exactly the same one, right? 2 sine theta cos theta. So those are actually equal to each other. So we can write that out now. So we can say this is 1 plus, and then either way, you could write this as, sine 2 theta, or you could have written them both the other way too, it doesn't matter. But that's equal to 1 plus sine 2 theta. Okay, so that one worked. All right, let's keep going. Okay, so how am I going to do this one? Well, yeah, just another little trick here, another little guy. What we can do, you'd want to just kind of mess around with it a little bit, and there might be more than one way of doing it, because I'm kind of looking at this being like, well, maybe I could rewrite the tan as sine over cos, right? And then you know, write the top like we did in that the other question a while back over the common denominator of cos. Maybe that would work. That probably would work, actually. I bet you he did that. But I'm going to do it a slightly different way. There's a few ways through this. Let's rewrite this. Well, and the other thing I'm going to do, I'm going to rewrite cos 2 theta. I'm going to rewrite it as something I'm a bit more familiar with. Like I want this cos and sine would be kind of a nice way to write it. So I'm just going to zoom in here so I try to make as much room as I can. Okay, so I'm going to rewrite cos 2 theta as cos squared theta minus sine squared theta. Okay, so I wrote it as that. It's equal to. Now, okay, so now, yeah, there is multiple ways of doing this. Like I just checked it out, and doing the top way, like the one we did like in the other question, that would work too. But I'm gonna just mess around with it a little bit different and show you that it can work another way too. So I'm gonna write this one. I'm just gonna split it up. So I'm gonna write this as 1 over secant squared theta minus tan squared theta over secant squared theta. So I just split them up, right? So they're just over, like, they're both over secant squared theta there. And then I'm going to rewrite this. So 1 over secant squared theta, well, that's the same thing as cos squared theta, right? So in my mind, like what I'm looking at here now, I'm like, okay, that's cool. That one looks like that one, right? So maybe I can turn all of this stuff into sine squared theta. That's kind of what I'm hoping here. So now this is tan squared theta over secant squared theta. So secant squared theta, right? That could be written, right? So if I'm just going to write tan squared theta again, right? Secant squared theta, that could be written as just cos squared theta up top, right? Because they're just inverse of each other. Now if I rewrite this, so cos squared theta minus, and now I'm going to rewrite tan as sine over cos. So sine squared theta over cos squared theta times cos squared theta, like where this is going. Cos squared thetas cancel, and I do actually end up with the same thing, right? Cos squared theta minus sine squared theta. So they end up being equal to each other on both sides again. Okay, and like we could have written this as, because this, right, is the same as cos 2 theta, so it could have been the same thing, cos 2 theta. Either one, as soon as you get them to look the same, it doesn't matter. Okay. So 3. We're almost done. So it says find the exact values without using a calculator of sine 2 theta, cos 2 theta, if tan. Whoop, move that over. How do we move that over? There we go. If tan theta is negative 3 over 4, and theta is in quadrant 4. Is a quadrant 4 end. All right, so let's kind of see what we've got going on here. So if I drew my Cartesian plane, it's in quadrant 4. I might just do that to begin with. And then what do we have? So this is my angle. So tan theta is negative 3 over 4, right? So tan, if I was doing the cash rule, right? Tan would be negative, you know, in quadrant 4, like we have. It would also be negative over here, but it told us it was in quadrant 4, so we don't have to worry about that one. Okay, so now if I'm looking at this triangle, right, I can figure out what was the negative there. Was the 3 negative, or was the 4 negative? Well, it must have been the y value, right? It must have been this one. This must have been the negative part of it. So negative 3, that's my opposite, and then 4 is my adjacent there. So that must have been the way it worked, right? So now, so negative 3 and 4, this is a 3, 4, 5 triangle, so you can do Pythagorean theorem, or you can just know that this must be 5 as well, right? Okay, so that's 5 for the hypotenuse. So now I've got everything I need here, right? So sine theta, is equal to, I'm just kind of going off of this, right? Where I'm calling like all of that theta. Hopefully, well, maybe that'll make sense in a second here. That's equal to negative 3 over 5, right? Opposite over hypotenuse. And cos theta is equal to 4 over 5. Okay, so now, we are going to rewrite sine 2 theta. So sine 2 theta is equal to 2 sine theta cos theta. All right, so I can figure out what sine 2 theta is. So sine 2 theta, because I can actually plug these ones in now. I know what those are. So that's going to be 2 times, and then cos theta, we said, was negative 3 over 5. So negative 3 over 5. Okay, and then cos theta was 4 over 5. All right, so if you figure that out, it ends up being negative 24 over 25. Okay, so there's that one. And it also wanted us to find cos 2 theta. So that's going to be similar. So I'll say cos 2 theta is equal to, and we'll do this one, cos squared theta minus sine squared theta. Okay, so cos theta was 4 over 5. So it's 4 over 5, but the whole thing's squared. So 4 over 5 squared minus, and then this was negative 3 over 5. And then the whole thing squared. So that ends up being equal to 16 over 25 minus 9 over 25. So that is equal to 7 over 25. Okay, so that's it. Okay. That's it. It was a long video. Sorry about that. But yeah, those are the questions.